Welcome to AGWA, the Automated Geospatial Watershed Assessment Tool video series. AGWA was developed by the University of Arizona with the USDA ARS Southwest Watershed Research Center and the US EPA. AGWA is available at www.tucson.ars.ag.gov/AGWA. Funding for these videos was provided by the Department of Defense Environmental Security Technology Certification Program, ESTCP. This is video 13B, Prepare Data for AGWA, Prepare Precipitation Data for SWAT. Video 12B showed how to obtain the data and should be viewed before viewing this video. This video will show how to create the two files required to run the SWAT model. The rain gauge point theme that provides the geographic location of the rain gauge or gauges, and the unweighted precipitation file that provides the actual daily precipitation amounts. We'll be using the NCDC data that was downloaded in video 12B. AGWA Video 6 showed how to prepare the precipitation data for Kinneros 2. We'll start with the unweighted precipitation file. This file must contain at least these three fields: the gauge ID labeled G and the 4-digit gauge identification number. These are the actual daily precipitation amounts. The year, and 3, the day, as the Julian day of the year from 1 to 365 or 366 for a leap year, for each year in the file. It's best to use multiple years of record if possible to capture long-term climate trends. Start with the 3138_PCP.CSV file downloaded from the NCDC website in video 12B. Save the original data as 3138_PCP_ORIG.CSV. In the 3138_PCP.CSV file, delete the first 5 columns: station, name, latitude, longitude, and elevation. These are not needed for the unweighted precipitation file. Leave the last 2 columns, date and precip, and save this file as an Excel file, 3138_PCP.XLSX. Next, we'll format the file. Rename the PRCP column to G3138 to indicate the gauge ID number. This column contains the daily precipitation values. To convert the date to year and Julian day, insert 3 columns after the date column and format them as number or general. Label these columns date, year, and day. To separate the date into year and Julian day, enter this formula into the date column to reformat the date. Copy this column and paste values only to the year column. Use the Text to Columns tool in Excel in the Data tab to split this date into year and day. You may need to use the Convert to Number function before using the Text to Columns tool. Next, select column C, use Fixed Width, and click Next. Create a break line after the year 2013. Click Next, and then Finish. Your data should now be separated into year and Julian day. Delete the first 2 columns A and B, leaving the 3 columns year, day, and G3138. Save this file. This is the unweighted precipitation file. Finally, you'll need to make sure the dates are continuous and that every day has an entry. Review the file and fill in any missing days with the date and -99 for the precipitation value. This data set for gauge 3138 is complete, so no modifications are needed. Save this unweighted precipitation file as 3138_pcp.csv. This file contains 2 full years of data that includes the mountain fire date of July 13th, 2013. Next, we'll create the rain gauge point theme for the geographic location of the rain gauge. Open the original 3138_pcp_orig.csv file and save it as 3138_gauge.csv. Delete all rows except the first 2 rows, 1 and 2. Add 2 new columns at the end of the table, end_date and gauge_ID. In the end date column, enter 2014-12/31, the last day of the precipitation record, and in the gauge ID column, enter 3138. Save this file as 3138_gauge.csv. Next, we'll create the rain gauge point theme from the CSV file. Add both the 3138_pcp.csv and the 3138_gauge.csv file to your ArcMap document. In the table of contents, right-click on the 3138_gauge.csv file. From the menu that appears, select Display XY Data. Select longitude for the X field and latitude for the Y field. Leave the Z field as none. Edit the coordinate system so it is Geographic Coordinate System World WGS 1984. Click OK to create the event. Click OK when the table does not have Object ID field message appears. Next, export the 3138_gauge.csv events as a shapefile. In the table of contents, right-click on the event. Select Data, then Export Data. Save the shapefile as 3138_raingauge.shp. Click OK, then Yes to add the data as a map layer. We're now ready to write the SWAT precipitation file. Go to AGWA Tools, Precipitation Options, write SWAT Precipitation. In the SWAT Precipitation Step 1 form that opens, select the Discretization, Rain Gauge Point Theme, and Rain Gauge ID field from the drop-down menu. Use the Select tool to select the Rain Gauge Point Theme in the map. Once it's selected, it will be listed in the Selected Gauges box. Click Continue. In the SWAT Uniform Precipitation form that opens, the Discretization, Rain Gauge Point Theme, and Gauge ID field will already be selected. Select the unweighted precipitation file you just created, 3138_pcp.csv, from the drop-down menu, and name the new SWAT precipitation file 3138. Click Write to finish writing the SWAT precipitation file. Now that you have the precipitation files for SWAT, you can perform a simulation, which is very similar to a Kinross 2 simulation, which was demonstrated in the previous videos. AGWA is available at www.tucson.ars.ag.gov/AGWA. This website includes the AGWA package with all of the models and lookup tables needed to run AGWA, tutorials and the data to run the tutorials, various publications and documents, and an FAQ section. These videos are intended to supplement and support the AGWA tutorials and online documentation. The next video will demonstrate some of the management tools available in AGWA.